All right, think about the last time you dropped something. Maybe it was a pen, your keys, or an apple from a tree. Picture it just detaching from a branch in slow motion, falling straight down toward the dark earth. It feels entirely obvious, right? It feels like an invisible hand literally reached out from the ground, grabbed it, and yanked it down. Now, for centuries, we've confidently called this a force. And hey, don't get me wrong, it's a super useful picture. It's the sketch that helps us calculate paths, build massive bridges, and even launch rockets into orbit. But here is the mind-bending truth. It is just a sketch. In this explainer, we're going to completely shatter that familiar illusion. We're stepping right past that everyday pull of the Earth to look at the hidden system underneath.
So what if gravity isn't a pull at all? I mean, what if there is absolutely no invisible hand? I want you to try and imagine that gravity isn't something aggressively yanking you downward. Instead, what if it's the very shape of the world around you gently telling you where you naturally have to go? We are about to completely reimagine gravity today. We're moving away from this idea of a mysterious, ghostly tug and toward the beautifully curved architecture of the universe itself.
Okay, let's dive right into this. The old picture, the one we all learned in middle school, asks a basic question. What is pulling the object? It assumes gravity is a force acting on things from the outside. But the newer, much more accurate picture asks a totally different question. It asks, what path is the object naturally following? This right here is the core shift. It means gravity is way less like a push or a pull, and actually a lot more like the ground beneath your feet actively guiding your footsteps along an old curved stone path. To really wrap our heads around this, we have to totally rethink the stage where everything in the universe happens. Imagine a vast, flat grid stretching endlessly across the cosmos. Now picture a massive, heavy sphere dropping right onto that grid, creating this deep, elegant depression in it. This brilliantly shows us that space and time are not just separate, empty stages where events randomly happen to take place. No, they are actually woven together into a single, flexible fabric. Mass doesn't just sit there in space like a heavy book resting on a wooden table. It acts more like a heavy bowling ball sitting on a stretched piece of trampoline cloth, literally warping and dipping the layout of the floor itself.
Let's define this crucial concept, so we're totally on the same page. Space-time is that linked, flexible fabric, and the key is that it can be dynamically shaped and distorted by the sheer presence of mass. This means the environment of the universe is active, it responds. Think back to that heavy sphere dipping the fabric. When a smaller marble rolls near it, it naturally curves inward. But, and this is huge, it isn't curving because the heavy object is reaching out and grabbing it. It curves because the path on the cloth is simply no longer flat. The background structure itself is what's guiding the motion.
Now here is a fundamental rule of the universe. Objects absolutely love straight lines. If you roll a ball on a perfectly smooth, flat floor, it just keeps going straight, because straight motion is the natural default when absolutely nothing interferes. An object actually requires a force to change its motion. To picture this, think about a shopping cart rolling down an endless supermarket corridor. We've all been there, right? Imagine one of its wheels is slightly misaligned. You push that cart straight, but it gracefully, unavoidably curves right into the shelves. Why? Well, it's not being magically yanked by some grocery store ghost. The cart's internal geometry forces it to turn.
Which brings us to this really beautiful realization. The motion is not being randomly yanked, it is following a path whose geometry has been altered. So when you drop an object and it suddenly speeds up toward the ground, or when a massive planet curves around a star, the most important question to ask isn't, why is it moving? The real question is, why did its path bend? Gravity is exactly that altered geometry. It is literally the misaligned wheel of the universe. Now, what's genuinely fascinating here is how this totally flips our common sense completely on its head. When you fall, it feels violently forced. But physics reveals a strange, honestly mind-blowing truth. Free fall is actually the most natural motion possible. Picture being in an old-fashioned elevator in a dark void. Suddenly, the cables snap. If you were inside, you actually wouldn't feel your weight pressing into the floor anymore. You would float. You'd be completely weightless, perfectly calm, just drifting as the elevator drops. Why? Because you aren't being forced to do anything. You are simply following the straightest possible path available to you in a curved world.
So, let's compare these two perspectives real quick. From the outside view, falling looks exactly like forced motion, like a downward pull. But the inside view, your actual physical experience floating in that falling elevator, tells us a much deeper story. You are simply following natural geometry. You see, a normal force, like someone physically shoving you, is something you feel directly as resistance. But a change in space-time geometry, that is perfectly subtle. You feel no shove, you feel no tug. What looks like a dramatic, aggressive pull from the outside is just a smooth path effect from the inside.
So if gravity is really just the shape of space-time, how in the world does that explain the cosmic dance going on above us? Why doesn't a satellite just crash straight into the Earth or, fly off into deep space? If we're abandoning the idea of a literal invisible rope of force tying a satellite to a planet, how do we actually explain an orbit?
Well, the answer is this incredibly delicate balance often called falling around. Think of it like this. A satellite is moving forward incredibly fast. That aggressive forward sideways motion is what keeps it from dropping straight down. But at the very same time, gravity, which we now know as the curved geometry of space, is continuously bending that satellite's naturally straight path inward. The satellite is constantly trying to go straight, but the warped space keeps safely turning it. The result isn't some mysterious compromise between two forces, it's just a perfect, stable loop in curved space-time.
In this geometry map, it explains the cosmos far, far better than the old pulling force ever could. Because if gravity is simply the curvature of space-time itself, then literally everything that moves through it must follow that curvature. Imagine a beam of pure light shooting past a massive glowing star. As it skims the curved space, it visibly bends. Now, light has no mass in the ordinary sense, right? So a traditional pulling force shouldn't affect it at all. But because the very fabric it travels through is warped, the light has absolutely no choice but to bend right along with it.
Okay, let's take this one step further, because it gets even wilder. I want you to imagine two watches. Picture one watch ticking right near a heavy, massive cosmic object, and the other watch ticking far out in empty, deep space. Here is the massive revelation. They tick at different speeds. That's right. Gravity doesn't just dictate the physical paths of objects in space, it actually dictates the rate at which time itself passes.
Gravity reaches into the rhythm of change. A pure pulling force story simply cannot explain this. I mean, a force can tell you why a rock accelerates downward, sure, but it has absolutely no natural way to explain why the fundamental structure of time changes just because you happen to be standing near a massive planet. But if gravity is the warping of space-time, meaning both space and time combined, then it makes perfect, elegant sense that a heavy mass reshapes the flow of time right along with the curves of space.
And just to show you this isn't some abstract, high-level philosophy, this brilliantly illustrates why it matters in your daily life. Think about global satellite navigation systems, the GPS right there in your phone. To work properly, these systems demand extremely precise timing between the satellites in orbit and your device on Earth. But because those satellites are further from Earth's mass, time actually flows slightly differently for them than it does for us on the ground. The system physically must account for gravity's effect on time. If it didn't, your GPS would be wildly inaccurate in a matter of minutes. This proves, without a doubt, that the Noor geometry model isn't just a fun physics idea. It is the literal physical reality we live and navigate in every single day.
Let's bring this all together and look at the whole picture. The force picture? It's great for everyday life. Falling feels like mass pulling an object down. An orbit looks like gravity balancing motion. It's kind of like a local street map. It gets you around your neighborhood safely and quickly. But the geometry picture is like seeing the whole terrain from a satellite view. Falling is just following curved space-time. An orbit is just moving along a naturally curved path. And when it comes to the extreme stuff, like light bending and time dilation, the force picture finds those really hard to explain or simply cannot handle them at all. But the geometry picture, it reveals these are naturally built into the geometry itself. So the new picture doesn't erase the old one, it completely absorbs it into a much broader, much more accurate framework. So what should you really take away from this explainer? I'd say the biggest mindset shift is this. Look for the hidden system, not just the visible effect. Our everyday human intuition is built for a small-scale life of walking, throwing, and catching. In that world, the familiar story is simply that things are pulled down. But relying on that trains us to stop trusting the first story that feels familiar. Instead of seeing an invisible hand yanking things around, we have to learn to see the complex, underlying geometric, cosmic background that actually shapes everything around us. To truly understand the universe, we have to look past the illusion. Mass shapes the stage, and motion simply follows the stage. As we wrap up, I want to leave you with this final, profound thought to ponder the next time you drop your keys or the next time you gaze up at the night sky. Gravity is not just what pulls things down, it is what makes motion take the paths it does. So I'll leave you with this question. What other invisible structural systems are shaping our world, hiding right there in plain sight, just waiting to be reimagined?